Overview and objectives. Hello children, today we will learn the basic types of chemical reactions and we will learn how to predict the products that are likely to be formed when these reactions occur. Hello children. We have learnt earlier that chemical changes result in the transformation of one chemical substance into a different substance having a new set of chemical and physical properties. The transformation of one substance into another is called a chemical reaction and is described using a chemical equation. There are many different classifications of chemical reactions. Let's learn about some types of chemical reactions in detail. Learning objectives. In this topic, we will learn about the types of chemical reactions. Combination reaction, decomposition reaction, displacement reaction, double displacement reaction, oxidation and reduction reaction, neutralization reaction. Meaning of a chemical reaction. Chemical reaction. The transformation of chemical substance into another chemical substance is known as chemical reaction. For example, rusting of iron, setting of milk into curd, digestion of food, respiration, etc. In chemical reaction, new substance is formed which is completely different in properties from the original substance. So in a chemical reaction, chemical change takes place. Following are the signs of chemical reaction. A. Change of state of substance. B. Change of color of substance. C. Evolution of heat. D. Absorption of heat. E. Evolution of gas. F. Evolution of light. G. Evolution of sound, etc. Reactant and product. Reactant. Substances which take part in a chemical reaction are called reactants. Product. New substance formed after a chemical reaction is called product. Chemical reactions can be classified in following types. A. Combination reactions. B. Decomposition reactions. C. Displacement reactions. D. Double displacement reactions. E. Oxidation and reduction reactions. Types of chemical reaction. Combination reaction. Reactions in which two or more reactants combine to form one product are called combination reaction. A general combination reaction can be represented by the chemical equation given here. A plus B gives AB. In a combination reaction, two or more elements can combine to form a compound. Two or more compounds can combine to form a compound. Or an element and a compound can combine to form a compound. Examples. A. Hydrogen burns in oxygen to form water. 2H2, which is gas, plus O2, which is gas, gives 2H2O, which is liquid. In this reaction, two elements, hydrogen and oxygen, are combining to form a single compound, water. So this is an example of combination reaction. B. Ammonia reacts with hydrogen chloride to form ammonium chloride. NH3 plus HCl gives NH4Cl. In this reaction, Two compounds, ammonia and hydrogen chloride, combine to form a new compound, ammonium chloride. E. When carbon monoxide reacts with oxygen, carbon dioxide is formed. 2CO plus O2 gives 2CO2. In this reaction, carbon monoxide compound reacts with oxygen element to form a new compound, carbon dioxide. Decomposition reaction. Reactions in which one compound decomposes into two or more compounds or element are known as decomposition reaction. Decomposition reaction is just opposite of combination reaction. AB gives A plus B. Decomposition reaction is carried out by applying heat, light or electricity. Example, when calcium carbonate is heated, it decomposes into calcium oxide and carbon dioxide. CaCO3 gives, in presence of heat, CaO plus CO2. In this reaction, one substance, calcium carbonate, is breaking up into two simpler substances, calcium oxide and carbon dioxide. So, this is a decomposition reaction. When a decomposition reaction is carried out by heating, it is called thermal decomposition reaction. Example, when lead nitrate is heated strongly, it decomposes into lead oxide, nitrogen dioxide and oxygen. That is, 2PbNO3 in presence of heat gives 2PbO, which is lead oxide, plus 4NO2, which is nitrogen dioxide, plus O2, which is oxygen. Electrolytic decomposition. Reactions in which compounds decompose into simpler compounds because of passing of electricity are known as electrolytic decomposition. This is also known as electrolysis. Example, when electricity is passed in water, it decomposes into hydrogen and oxygen. 2H2O in presence of electricity gives 2H2 plus O2. This decomposition reaction takes place by the action of electricity. It is called electrolysis of water. Photolysis or photo-decomposition reaction. Reactions in which a compound decomposes because of sunlight are known as photolysis or photo-decomposition reaction. Example, when silver chloride is put in sunlight, it decomposes into silver metal and chlorine gas. 2AgCl in presence of sunlight gives 2Ag plus Cl2. Similarly, when silver bromide is put under sunlight, it decomposes into silver metal and bromine gas. 2AgBr gives, in presence of sunlight, 2Ag plus Br2. Photographic paper has coat of silver chloride, which turns into grey when exposed to sunlight. It happens because silver chloride is colorless while silver is a grey metal. Uses of decomposition reaction. The decomposition reactions carried out by using electricity are used to extract several metals from their naturally occurring compounds like chlorides and oxides. Example, aluminium metal is extracted by the electrolysis of molten aluminium oxide. Decomposition reaction in our body. Digestion of food is an example of decomposition reaction. When we eat foods like wheat, rice, or potatoes, the starch present in them decomposes into simple sugars like glucose in the body, and proteins decompose to form amino acids. Displacement reaction. Reactions in which atoms or ions move from one compound to other to form new compound are known as displacement reaction. Displacement reaction is also known as substitution reaction or single displacement or replacement reaction. A general displacement reaction can be represented using chemical equation as follows. A plus BC gives AC plus B. Displacement reaction takes place only when A is more reactive than B. If B is more reactive than A, then A will not displace C from BC and reaction will not take place. Example: when zinc reacts with hydrochloric acid, it gives hydrogen gas and zinc chloride. Zn plus 2HCl gives H2 plus ZnCl2. When zinc reacts with copper sulfate, it forms zinc sulfate and copper metal. Zn plus CuSO4 gives ZnSO4 plus Cu. In this reaction, zinc displaces copper from copper sulfate compound so that the copper is free. This displacement reaction takes place because zinc is more reactive than copper. When silver metal is dipped in copper nitrate, no reaction takes place because silver metal is less reactive than copper. Ag plus CuNO3 gives no reaction. Double displacement reaction. Reactions in which ions are exchanged between two reactants forming new compounds are called double displacement reactions. A general double displacement reaction can be represented using following general chemical equation. AB plus CD gives AD plus CB. Example: when solution of barium chloride reacts with the solution of sodium sulfate, white PPT of barium sulfate is formed along with sodium chloride. BaCl2 plus Na2SO4 gives BaSO4 plus NaCl. In this reaction, two compounds, barium chloride and sodium sulfate, react to form two new compounds, namely barium sulfate and sodium chloride. An exchange of ion takes place in the reaction. In this reaction, barium sulfate is formed as a white insoluble solid called precipitate, which separates out suddenly from the solution. Double displacement reaction in which an insoluble solid called precipitate is formed that separates from the solution is called a precipitation reaction. Neutralization reactions are also examples of double displacement reaction. Neutralization reaction. Acid-base reaction. When a strong acid and a strong base solution are mixed, a neutralization reaction occurs, and the products do not have characteristics of either acids or bases. Instead, a neutral salt and water are formed. Example: the combination of hydrochloric acid and sodium hydroxide produces common salt, that is NaCl. HCl plus NaOH gives H2O plus NaCl. The anion from the acid Cl- reacts with the cation from the base Na+ to give a salt. A salt is defined as any compound formed whose anion came from an acid and whose cation came from a base. When a strong acid and a weak base are mixed, the resulting salt will be acidic. Likewise, if a strong base and a weak acid are mixed, the resulting salt will be basic. Example: acidic salts are prepared by neutralizing a weak base such as ammonia, that is NH3, with a strong acid like HCl. NH3 plus HCl gives NH4Cl plus H2O. The word neutralization is used because the acid and base properties of H+ and OH- are destroyed or neutralized. In the reaction, H plus and OH minus combine to form HOH or H2O or water molecules. Exothermic and endothermic reactions. Reactions which produce energy are called exothermic reactions. Most of the decomposition reactions are exothermic. Respiration is a decomposition reaction in which energy is released. When quicklime, that is calcium carbonate, is added to water, it decomposes and releases energy. CaO plus H2O gives CaOH whole 2. On the other hand, reactions which absorb energy are called endothermic reaction. Most of the combination reactions are endothermic. Cooking involves chemical reactions which are endothermic, as cooking is possible because of heating. Oxidation and reduction reaction. Oxidation. Addition of oxygen or non-metallic element or removal of hydrogen or metallic element from a compound is known as oxidation. Elements or compounds in which oxygen or non-metallic element is added or hydrogen or metallic element is removed are called to be oxidized. Oxidizing agent. Compounds which can add oxygen or a non-metallic compound or remove hydrogen or metallic element are known as oxidizing agent. Reduction. Addition of hydrogen to metallic element or removal of oxygen or non-metallic element from a compound is called reduction. The compound or element which undergoes reduction is called to be reduced. Reducing agent. Compounds or elements which can cause reduction are called reducing agents. In a chemical reaction, oxidation and reduction both take place simultaneously, and such reactions are also known as redox reactions. In the word redox, red stands for reduction and ox stands for oxidation. Example. Number 1. When iron reacts with air, it forms iron oxide, that is rust. 4Fe plus 3O2 gives 2Fe2O3. In this reaction, oxygen is added to iron, thus iron is oxidized. Here oxygen is oxidizing agent. Number 2. When cupric oxide reacts with hydrogen, it gives copper and water. CuO plus H2 gives Cu plus H2O. In this reaction, oxygen is removed from copper and oxygen is added to hydrogen. So, cupric oxide is reduced to copper and hydrogen is oxidized to water. Cupric oxide is oxidizing agent and hydrogen is reducing agent. Number 3. When sodium hydroxide reacts with hydrochloric acid, it gives sodium chloride and water. NaOH plus HCl gives NaCl plus H2O. In this reaction, sodium hydroxide is reduced to sodium chloride since hydrogen is removed from sodium hydroxide. Hydrochloric acid is oxidized to water since oxygen is added to hydrogen chloride and non-metallic element chloride is removed. Sodium hydroxide is oxidizing agent and hydrochloric acid is reducing agent. In this reaction, oxidation and reduction both take place simultaneously. Thus, it is an example of redox reaction. Some other examples of redox reactions are: ZnO plus C gives Zn plus CO. MnO2 plus 4HCl gives MnCl2 plus 2H2O plus Cl2. Significance of oxidation reduction in everyday life. Number 1. Respiration is oxidation reaction in which food is oxidized to produce energy. Number 2. Iron gets oxidized to form rust. which leads to corrosion of iron in the long run. Number 3. Most of the metals react with atmospheric oxygen and it leads to formation of a layer on the metal article. The metal gets corroded in the long run. Number 4. Rusting of iron can be prevented by painting the iron article. This can also be prevented by applying a layer of zinc over iron article. This process is known as galvanization. Number 5. Fried food gets oxidized when exposed to air. This spoils the taste of the food and the food becomes unfit for consumption. The spoiling of fried food because of oxidation is called rancidity. Fried food is often packed in airtight packets to prevent rancidity. Number 6. We are able to utilize various types of fuel because of oxidation. Oxidation of fuel helps in producing energy. Summary. Students, we have thus come to an end of this topic on types of reactions. Hope you all now clear with the concept. Tomorrow, we will meet again with yet another interesting topic. Bye for now. Children, we now got a detailed explanation on the types of reactions. Hope this explanation will be helpful to you. Summary. In this topic, we have learnt about the types of chemical reactions. Combination reaction, decomposition reaction, displacement reaction, double displacement reaction, oxidation and reduction reaction, neutralization reaction.